On our final chapter of the Hole Cleaning Pillar series, we are going to explain the importance of the mud law and rheology in the hole cleaning system. Rheology is critical for efficient hole cleaning. If sufficiently high and combined with rotation, and assuming there's an adequate annular velocity, the viscous coupling effect and the rotational energy work together to mobilize the cuttings from the low side and efficiently carry the cuttings uphole. Here, we see two test setups using the same flow rate and pipe RPM. However, it can be seen that the setup using the higher rheology fluid dispersed the cuttings accumulation on the low side, despite the low RPM. At the initial entry point of the fluid into the test section, the flow regime is turbulent, and it takes some time to transition to laminar flow, which is the typical flow regime around the drill pipe in most drilling environments. The hole cleaning challenges we've been discussing are related to cleaning around the drill string, as the turbulent flow, high annular velocity, and the mechanical agitation of the cuttings bed results in efficient hole cleaning around the VHA. In a typical non-Newtonian drilling fluid, shear stress changes as shear rate changes, which defines the fluid rheology profile at different fluid velocities. For a given flow rate, the velocity of the circulating fluid changes as the internal diameter of the conduit it is flowing through changes. The smaller the internal diameter, the higher the velocity and therefore the higher the shear rate. In a drilling circulating system, the highest velocity will be through the bit nozzles, and the lowest velocity will normally be in the annulus. This is why it is important to monitor the low end rheology, specifically the 6 RPM reading, which is recommended to be in the range of 1 to 1.5 times the hole size in inches. Hopefully, this chapter have helped you understand why the low end rheology is key in the hole cleaning system and the impact of it in the fluid cuttings carrying capacity. This series should have helped you provide with a good understanding of the key considerations for efficient high-angle hole cleaning. If you'd like to know more about hole cleaning or other critical aspects of high-angle well engineering and operations, please get in touch with the Merlin team. In the meantime, good luck keeping your well clean and stable.